Ecological Resilience in Northern Watersheds. Jennifer's from Wilfrid Laurier University.
Okay, so I'm going to give you a bit of a warning. I'm one of the dreaded biologists we heard about earlier. And thankfully, seems as though Howard was more favorable toward biologists because he really supported us through the Changing Cold Regions Network in our tangents along, scientific hypothesis testing related questions to questions relating to changing cold regions. And so it's been a pleasure working with Howard over the last several years, and it's been a delight hearing about all of the work he's done with all of you. These are times before I knew Howard, obviously, and it's very humbling to hear about all of that he's done. Okay, so we've heard a lot about a lot of changes that are happening at the planetary scale in different parts of the world. Obviously, climate change is a really overarching driver of this, but we can think about sort of safe operating spaces for human societies. So we've lived on this planet for a fairly long period of time, and the conditions that permit our survival and our how well we've done on this planet. And there are a number of factors that are important for our continued persistence and that of other species on this planet. There are parts of when we think about safe operating spaces, these are the conditions that are similar to what we've had over the period of time that we've been occupying the planet. And then you get into places where things get a little bit riskier, what might be termed as a zone of uncertainty in sustainability science. And then you get into these areas where we're beyond the zone of uncertainty, and it's a high-risk situation. We heard about phosphorus and nitrogen earlier. And this part of the sort of safe operating space is what is the area that I work on. And when we think about land system change, the really critical components of the land system from a global perspective are the forested ecosystems. These are the sort of reservoirs for carbon. These are the lungs of the planet, and they're changing in lots of places really rapidly. So this is a place that I've spent a lot of time working in Southeast Asia, and we can see that this has moved into this red high-risk zone, largely due to really rapid deforestation and massive changes in land use. A place that I work more now is up in this region, and we can see that the boreal is in this zone of uncertainty, and we just heard about some of the activities here in Canada that contribute to that. But high latitude warming is another component of that that's really driving uncertainty in what the boreal will look like in the future. And in terms of water, we've heard of lots of places that are running out of water, but the boreal is one of these places that has massive amounts of surface water, and indeed is the world's largest. Canada's boreal is the world's largest source of unfrozen fresh surface water. And so you see these sort of repeated, these pictures where water is such a prominent feature on the landscape. And you can look at that in sort of the context of this map. It looks a little grainy up there now, but these different colors, the places that are blue, dark blue, are places that have greater than 10% of the pixel area covered by water. And so you can see much of Canada as this big blue blob, and indeed much of Canada is boreal. So we're home to a lot of the global surface water, but these places are also places that are changing really rapidly with climate warming. So much of Canada's north has warmed in excess of 3 degrees average annual temperature increases since the 1950s, and predictions are that will continue. So a lot of change in a place that stores an awful lot of fresh water for the planet. Okay, so I'm going to take an ecological perspective on this, obviously. So some of the advances in the last few decades, a really big one has to do with this idea of ecological resilience. So this is Buzz Hulling. He proposed this idea of ecological resilience back in the early 70s. And this has been a really important concept in ecology when we're thinking about changes in ecosystems in the face of climate warming. So this idea, it's different than the engineering term of resilience. This is the ability of a system to absorb disturbance and maintain the components and relationships that define that system. So if you look down at this little diagram, you have a state, and since I like forests, it's going to be a forested state here, and you disturb that system, and that little ball kind of bounces up and down and returns to this attractor region on the land, on this landscape. So what happens in the face of global change? Well, with a warmer climate, that attraction may be less, so you alter the system, you reduce its resilience, but also you have the potential to increase these disturbances that perturb the system. And so in this case, you can push that system right up over this threshold and into some new state. So this can be some non-forested state or a different forest type. So when we're thinking about these large expanses of forest, the potential for widespread change is really important in terms of uses of the land, but also in terms of thinking about hydrological changes. Okay, so what does this look like? Well, of course, we've seen this figure already, so certainly this part of things is happening. There's all kinds of other things that are happening in tandem with warming. So this is a picture of a permafrost landscape in the discontinuous permafrost zone. So in this landscape, you have forested lands occurring on permafrost, and these wetland areas are permafrost-free regions. Now with warming, we're seeing increasing frequency of what we refer to as thermokarst. So basically thaw leading to settlement or other disturbance on the landscape that has really big impacts in terms of the function. And so in this particular case, and this has been work that colleagues in the CCRN have really focused on, thaw in these permafrost landscapes not only leads to loss of forest and a massive change in this vegetation ecosystem, but increased runoff from the system that may, and I like this term that you guys use, that may lead to dewatering of this system. Wildfires. So the boreal forest is defined by disturbance events, widespread insect outbreaks, wildfires. But with warming, we're seeing increasing areas of forest burning every year. In the past 4 years in Canada, we've had 4 exceptionally large wildfire years. And the frequency and the severity is expected to increase as well. And so this changing fire regime can be the driver that pushes this up and into a different system. And indeed, work in a number of boreal ecosystems has shown that with increases in severity of wildfire, we can see shifts in the type of forest that returns after fire. In Alaska, for example, there's a shift. When you burn a sufficient amount of organic layer away, there's a shift from conifer-dominated to deciduous-dominated. So from a hydrological perspective, this changes the water use by the ecosystem quite dramatically. And obviously, these factors can feed into these factors. So we have interacting disturbance factors on the landscape. And then insect pests. This is another feature of boreal ecosystems that has been in place for a very long time. But with warming, we're seeing reductions in these killing temperatures that limit pest loads and sort of break some of these outbreak cycles. The other thing that warming is leading to is expansion of ranges of insect pests. And this has been evidenced in the massive forest mortality that we've seen associated with mountain pine beetle in much of Western Canada. And obviously, these kinds of changes have huge ramifications in terms of the functioning of that ecosystem and links back to particularly wildfire in terms of susceptibility. So all kinds of changes in the size of this disturbance arrow that can pop these systems into along other successional trajectories. So I guess the key message here is that we're seeing sort of loss of key legacies, physical legacies, disturbance legacies that have maintained the system in the state that it's in for a very long time, and has the potential to result in something that's fairly hard to predict. So I guess if you think of a well-behaved ecosystem, some external condition drives some linear change in that ecosystem, but most ecosystems aren't very well behaved. And in these boreal ecosystems, these changes in these threshold changes, this shifting into a new successional state, will look something like this, where you're going along hunky-dory and things seem good, and then you have this disturbance event coupled with warming that we're seeing that has reduced the resilience of the system, and it drops down into some other new state. So we see these ecological thresholds or regime shifts that are very, very hard to predict. So I just thought I'd talk about a couple of things that may be useful, a couple of directions that may be useful in terms of thinking about resilience or trying to predict where a system may change rapidly. And one of those ways is obviously remote detection of forest change. There's all kinds of amazing new imagery that's coming online that lets us monitor the status of forests. And one example of this is this measure of productivity. We can see, this is the world from above, and so we can see this nice greening. So green areas are increasing productivity, brown areas are decreasing productivity. So we see this nice greening in the Arctic and up at tree line locations. But we see that much of the boreal is sort of showing this more browning trend, decreasing productivity or no change. And when we look at that compared to, so each of these dots here is a site where tree ring analysis was done, and you can see very close correspondence between these satellite records and the tree ring records. So there's real potential to monitor forest health from these satellite, using these satellite methods, but also tree ring records hold all kinds of information that may let us detect when thresholds are about to be crossed. And indeed, what we see in tree ring records when trees are getting stressed close to the point of mortality is that they'll change there will be a period of high variability in growth, and then they'll drop down to some reduced growth rate before mortality. So it seems possible to make use of these sort of widespread records to figure out where are there going to be places in the landscape that may be most susceptible to change or compound disturbances. Similarly, bringing together all kinds of geospatial information to think about things like probability of thermokarst that may lead to big changes hydrologically or big changes from a forest cover perspective. And so this is some really nice work done by David Oldefelt and others at the circumpolar scale, where we see the probability of different thermokarst features showing up in the landscape. And this is work that we're trying to take and move into the Northwest Territories to think about, okay, at the smaller scale where managers are working, where are these thermokarst features likely to be? And some examples of these, you've already seen this example where we have wetland and forest and conversion from forest to wetland when thaw happens. Here's another great example. This is a massive active layer detachment. Basically, the permafrost thaws at the active layer, and the active layer sort of slides off along that ice active layer interface. And these can grow to massive sizes, many kilometers squared, and in this case, this active layer detachment crawled its way up this hill slope, and you can see this perched lake here, and indeed, that lake wall was breached, the permafrost into that lake was breached, and there was a catastrophic, flood, that lake catastrophically drained. So these kinds of sensitive landscapes are really important to think about when we're contemplating what this system will look like moving forward. Okay, so looking into the future, I liked this. Pat said this yesterday. We have to get busy even though water is flush in many places. Indeed, the boreal is one of those places where water is very flush. But again, one of these places where we're seeing really rapid change associated with warming and increasing strength of disturbance events. And so some of the ways we're moving forward on this is thinking about, well, as we look forward into a warmer planet, where will boreal forests be that they currently are? Can we identify places in the landscape that will serve as refugia for boreal ecosystems? Some of these things are physically driven. So, for example, valleys where cold air pools. Some of these places can be really buffered from climate warming, and so can have very slow climate change despite more regional warming. And so these are places that we expect will be important refugia, but also places that are more resilient to change. So places that aren't necessarily going to face the same kinds of pressures, or that are resilient because of certain ecological features. And so Sean was showing you places where they're regrowing peatlands, but peatlands are incredibly resilient ecosystems because moss just doesn't like to go away, and it doesn't like to let other things grow there. And so we have certain parts of the landscape that may be very resilient because of biological reasons. So identifying those places that are resilient, or where physical processes moderate the climate and allow for maintenance of boreal ecosystems. And then thinking about spatially explicit ecological models. For anyone who was at the CCRN, we saw a nice talk by Alan where he showed some sort of projections that a few ecologists in the CCRN group had put together in terms of what change we might see at the landscape scale in boreal ecosystems or across the CCRN domain. It was our kind of expert opinion on this, but we can do a lot better than that. And we're working on something called the spatial discrete event simulator, and it's a modeling framework where we can actually build a lot of these processes, thermokarst processes, fire models, insect disturbance, successional change, and the responses of the vegetation, these nonlinear responses, into a spatially explicit framework that can interface with the hydrological modeling community to provide better predictions of what the land cover may look like in the future. So I think that this is an important direction that we're going that will be really helpful in informing what that ecosystem will look like, and how function will change and impact the hydrology of the region. Okay, and with that, I'm going to thank you. Yes.
Great talk.
Thank you.
You mentioned high variability in productivity before the collapse. Mm-hmm. Is that an example of flickering? Like, there's a number of different mechanisms being...
Is it an example of what, sorry?
Of flickering. I'll explain, like, in
right.
Regime shift prediction, there's a number of ideas about signals before they happen. And
yeah.
one of them is, and a lot of them contradict, but it seems one of them is flickering, like rapid, like you sort of move into the new state, come back to the old one.
Yeah, yeah.
And then the inevitable...
Yeah, and certainly in the tree ring record, that's the kind of behavior we see, greater variability, and then it sort of drops to a low level, and then that tree is sort of on the way out. And so trying to figure out whether we can pick up those kinds of signals using broader scale imaging, whether or not that actually is possible, I'm not sure.
So are you planning to test those ideas, some of those hypotheses about forecasting these?
Don't have that on the immediate horizon.
Sure.
I think it's a neat direction to go, and I'm sure there are others working on that. But I think figuring out what those cues are, and that was just one example of the kinds of cues that give us insights into these threshold responses. But that's going to be really important if we're thinking about trying to, in systems that we think are particularly important parts of the landscape, perhaps thinking about trying to manage if we see a system poised for some kind of change. Is there a management
For sure.
A management tool we can use to help mitigate that? So, yeah.
Thanks.
You're welcome.